Welcome back to The Tech Between Us. We continue our conversation about Industry 5 with Leonardo Dentone, Programme Chair of ISA Denmark. To catch up on part 1 of our conversation, visit our Empowering Innovation Together website. So let's talk about digital transformation and the journey that organisations take when adopting digital technology. What we're calling Industry 5, Industry 5.0, what are the typical drivers that bring an organisation to the conclusion that this is the way forward for us, this is the kind of approach that we need?
So I will talk about the 3 different pillars of Industry 5. So if we talk about sustainability, it's becoming real, it's becoming concrete in the form of incentives. Policymakers are starting to make us pay for our emissions, are starting to make us pay for the impact that we are exercising on our planet. So that is, if anything, if it doesn't stem from a noble cause of making better use of our resources, it's become really tangible. So that's one of the drivers, right?
Yeah, financial persuasion, we could call that, to become more sustainable.
Absolutely, and especially competitive advantage in several markets. If consumers are starting to prioritize sustainable products and they are willing to pay a premium for them, then companies that will be able to offer these sustainable products and prove compliance to specific targets, then they will have a competitive edge. And we see so many companies in so many industries, mainly the market leaders, they are refining the value propositions in this direction, obviously, to gain competitive advantage. If we talk about resilience, well, that's the biggest example is COVID. So it's really about becoming more agile, becoming more able to react more quickly to whatever happens in the world. But I also like to frame resilience not just as agility, but as business continuity and risk management. I see 2 faces of the same coin, really. And if we talk about what we have just explained in terms of being able to attract and retain the workforce, you will need to run your factory. That's really about business continuity, right?
Yeah, I see.
The third one is, I like to explain this one thinking about my own professional experience. When I started my early days as consultant, I thought that change management was nothing else than some consulting trick to sell more projects and to sell less technical things to technical people and stress the importance of it. Then I started realizing by having a more and more active involvement in many industrial networks related to industrial association that those gray-haired engineers, 60-year-olds, were always telling first and foremost about change management. And that came from the hard realization, having made mistakes in their own careers, that you may have the best technology, but if you don't really build it around people and processes and you don't fulfill the real needs and you are not good at communicating what's in for them, then your technologies will never fly. And it's an interesting outcome of the convergence of 2 worlds that were historically separated, the IT world and the OT world. So when we talk about user adoption and change management in the IT world, is something that sounds relatively old. It's no news, at least. Everybody has heard of it in the IT world before. But the OT world is characterized by much, much longer innovation cycles. Obviously, being connected by OT, I'm talking about operational technology. So the assets on the shop floor, the machinery, and everything that controls them. So the OT world, being asset heavy and capital heavy, is characterized by much slower innovation cycles. Therefore, not having to innovate that frequently, it was news that there had to be a focus on change management also in this world. So as technologies typical to historically belonging to IT, for example, cloud computing, artificial intelligence, and so on and so forth, are being applied to shop floors, to operational technologies, then these 2 worlds are converging, and then you suddenly see the same need in OT, and it looks like it's a new need, but it's really always been there.
There's a couple of points come out, I think, because going back to sort of how you formulated the answer around the pillars of Industry 5, then there are commercial, operational, and you used the term business continuity, which I think is a really good term. And that leads us on to the retention of your workforce, upskilling, building that engagement in the workforce, whatever age they might be. And then the importance of something we covered in an earlier question was how you make the interface between the individual and whatever process they're working in. As you bring in that new technology, critical that it's an intuitive, easy to use, easy to understand interface, and the complexity at operational level is designed out. So the process continues, but people have become very quickly very comfortable with what's being asked of them.
I like to add one perspective to it, which is sometimes it's not just removing complexity out of the process, but being able to, if you have engineers that have been on shop floors for 30 years in the same factory, they hold a massive amount of knowledge about the company and its processes. And that knowledge is not necessarily captured or shared. So talking into business continuity, when they will leave, the knowledge will live with them. So being able to bridge this knowledge gap to newcomers on shop floor, that will become really essential. And then that is not necessarily simplifying the processes, but is making the knowledge, the understanding of this complexity available to a wider audience. And it's also being able to tackle this complexity together. Because if suddenly you start founding technology communities, for example, then suddenly you may have engineers factory of the same company on the other side of the world that have figured out a solution to your problem. And they are able to share it with you, something that historically has not been the case. And I think I would like to highlight many large corporations have grown through mergers and acquisitions. And they have historically different ways of working, different maturities across the world. And they may have or have not been used to collaborate with different sites and different people across the organization. So this knowledge sharing may not be there simply.
But there's a level of technology available now that makes that process possible in I guess I'd just describe it simply as in a quick and easy way, both capturing and sharing the information. Let's move on and talk a little bit about this realization around the three pillars. That's really the foundations and the reasons why people take this journey, why organizations take this journey. And let's talk a little bit about what that journey looks like, because a new client comes to you, they want to talk about digital transformation. How do they get started? Is it looking at what's going on at an operational level, on the shop floor level? Or is it looking at the desires or the business objectives of the C-suite level, or a combination? Give us a sense of what that looks like.
It depends on many, many things. It depends on the industry. It depends on region. For example, it looks very different in the construction industry, in the food and beverage, or in the oil and gas, the starting point of this transformation. Many times it's leaders that are just confused by the staggering amount of sales material that they are bombarded with. Suddenly there is all the technologies look like the right solution to their problems, and they have visited one of their factories and they've seen too much paper on their shop floors, or really they might come with very different needs, or they might be just very frustrated because they have visited a few of their factories and they've seen that they solve similar problems in many different ways, and they are uncoordinated and they just want to hear what is the right way forward. So
there's duplication, perhaps, duplication of effort.
Yeah, absolutely. So my experience is that it very much depends on the industry, how automated, how regulated that industry is, how capital intensive that industry is. It's very different if we talk about oil and gas and the construction industry or food and beverage. Depending on really the nature of the production line, the origin may be different. It also is very largely dependent on where in the world we're looking at this transformation.
If you think about, the industrial nations of the world, there's so much legacy, discrete industrial equipment out there. Of all the reasons that we've explored, the good reasons to go on this journey, I guess there's a level of complexity to retrofitting or bringing into that sort of Industry 5 era the legacy hardware and equipment that's out there. So if we think about that deployment for a second, what are we talking about in terms of hardware and software, briefly? Because I guess that could be a long story. And are there any frameworks that help with that structured approach?
So the answer to this question is that it depends on so many different factors, because all the factors are different, even within the same industry, even within the same company. And when we talk about digital transformation, we talk so often about, we mainly, I would say, talk about retrofitting, about brownfields. We rarely build a factory from scratch. That is the way we would like it to look like. We need to adapt what we have. We need to bring what we have in the modern world. And within the industrial automation world, it's very complex. It's a plethora of technologies at many different levels. So how do you look at them? One very good way to look at them, and I will become a missionary of ISA, is by structuring and isolating different areas through the ISA 95 framework, which is a standard, a globally renowned standard within industrial automation. And this standard is made of 4 levels, 5 really, because level 0 is the physical production process. And then if you go one level up, you will have the sensing and manipulating level, which is about collecting data through sensors from the physical production processes and manipulating the production processes.
So the likes of temperature, pressure, humidity, proximity sensing, a whole variety of parameters you could look for in a production process.
Think about a valve that is opening and closing depending on specific parameters, right?
Yep.
When we look at level 2, it's about control and supervision of your industrial equipment. So SCADAs,
PLCs in there,
human machine interfaces, and really bringing this data together and being able to control it through digital tools that are not simply automated as an automatic valve, for example. If we look at level 3, we jump deeper into the software realm. We look at manufacturing operations management software. That is a variety of software that orchestrates data flows within the factory walls, coming from many different sources. One of them may be, so actually ISA structures it in 4 domains: production, inventory, quality, and maintenance. Production are manufacturing execution systems, so all those software that are able to do a series of actions that are able to control really the manufacturing process. The maintenance may be the CMMS of this world, so computerized maintenance management systems, building management systems, and then when we look at inventory world, there may be some warehouse management systems or something that is more closer to the production. So inventory on shop floors, not just in your warehouse and distribution centers. And then when we look about quality, you may have laboratory information management system, LIMS, or QMS, quality management systems, and so on and so forth. And then if we go one level above, we are looking at business planning and logistics. So the ERP of these worlds, the software that is overarching. So while level 3 looks within the factory walls, what is happening on shop floor, in the inventories, in the factory, and is able, for example, to translate the demand that is coming from level 4 into a production plan. We are looking at different latencies as well. So different times to react to specific information and different time horizons. When we look at level 4 translates market demand into what the organization needs to produce. So at an organization level, at a business planning level, not at a factory level, not at a line level for sure. That's happening in level 3 of the ISA 95 framework. So this framework also outlines a lot of different functionalities that these softwares and components have, and that orients organizations into a direction that is a standard way to modernize their processes and technologies, just by looking at the capabilities that are available out there in this software and hardware in the automation world. And then you may have, I think I like to bring this example about being able to optimize for energy prices. So you may have different maturities within your 4 levels of the ISA 95, right? There may be companies that when looking at energy monitoring, they will just be just monitoring how much energy is being consumed by a specific batch production process or at an item level even. And there will be companies that, like Tesla does in some of its production facilities, that they are able to reschedule specific production processes based on energy prices. So if electricity has skyrocketed in price over the last couple of months or so, then production facilities in Tesla, they are able to translate this information coming from the outside of the factory walls into a production plan that is less heavy on energy-intensive process, and therefore not just obviously looking at the bottom line, but also at the sustainability aspect of this.
So optimizing the energy usage based on the processes, so really understanding from a granular level. And certainly, if you look at the kind of technology that we carry as a distributor, then we can really enable people to get this information from a variety of different sort of energy monitors, and also then to think about the technology that they could deploy that would help them reduce their energy consumption generally. And that's something we see actually from the very smallest components to the very biggest, and things like efficient motor control, again through to that, the monitoring technology as well. But just going back, you paint a very complex picture there. So how often, let's think of this in a different way, typically are organizations blessed with the right expertise in-house, or are they often reaching out for consultancy? Because that complexity of those different layers, the operational data with the management systems and so on, the latencies involved, very different on the factory floor when you might be talking about time-sensitive networking, to an aggregate view that's presented in a management system on a more, it's less time critical, let's say, to keep painting that picture. So is that complexity often supported by outside expertise?
Yes, in a nutshell, yes. It's definitely most times the capabilities are not available in-house. And I will spend a few words on why this is a very complex transformation to tackle. When you approach this kind of transformation, you need to bring together knowledge from the IT world, because you're really dealing with informational technologies. You are dealing with industrial automation, so people that are able to program PLCs and act on machinery on shop floors. You need knowledge from people that understand operations and ways to optimize productions and supply chain. You need knowledge from people that are able to translate optimization business needs into a plan. So you need program and portfolio managers. You need to sell these ideas and these approaches and these investments to management, because they're ultimately those that are paying, and not necessarily the engineers on shop floor that are living daily with these problems. They are able to sell solutions to management. And you are dealing with really many different words that are used oftentimes to work in silos. So they're not used to collaborate. And you may need to outsource part of this knowledge. And generally what we see and what we have advised clients to do is that they would outsource relatively heavily in the first phases of the transformation, when they need some outside-in perspective on how to best approach it and where to start and where the most value lies. And then they start building capabilities within their organization to a split that is a rule of thumb. I'm quoting now a really good book that is called Rewired for Digital Age by McKinsey, that defines that the optimal split in the long term is 70% internal capabilities and 30% outsourced.
Yeah, undoubtedly there's some specialist knowledge needed to bring together the complex worlds that you're talking about. There's a couple of things come up again there, I think. One is that the business case needs to be strong, and we've touched on that a couple of times. Ultimately, it comes down to P&L. And we've set out kind of the good reasons for going on this journey, but there'll need to be a commercial imperative as well, won't there, to really support the business case. Let's just move on and talk a little bit about when you go through deployment, and we talk about how the kind of new things that come along with that deployment. So one of them would be, and this is a common topic, right? Cybersecurity, where we start to gather data at an operational level, which perhaps we didn't before. When we think about cybersecurity, you think about attack surface and vulnerabilities. Have you seen, or how do organizations ensure that they are gathering that operational data in a secure way, that they're not exposing themselves to risk, to whatever comes with that? And we've all heard the horror stories, of course, in the press.
So cybersecurity is becoming top priority together with safety on shop floors. It is becoming as organizations are receiving an external push from regulators. For example, in Europe, we are very much talking on a daily basis about this NIS2, which is this enormous incoming regulation about OT cybersecurity, so cybersecurity on shop floors, that came, as many experts like to state, it brings the cybersecurity topic at the board level, from the shop floor level to the board level, because it's putting responsibility personally and liability personally on board members. So they are facing huge fines if they don't comply with the at least basic cyber hygiene. And these regulations are distinguishing between industry and the criticality that specific industries have on society. So obviously, when we talk about defense sector, when we talk about water distribution, when we talk about medical and pharma, these sectors must comply to much more stringent rules in terms of cybersecurity than other sectors that are less critical for society to run.
And what you describe are all big users of industrial automation.
Absolutely. And I find it interesting when we talk about cybersecurity within industrial automation, within OT world. It's different compared to the IT paradigm of cybersecurity, which is, if you talk about cybersecurity in IT, is about confidentiality, integrity, and availability of information. So priority in the IT world is making data not accessible from the outside, confidentiality. And then making sure that the data that is transmitted is the one that was supposed to be transmitted, so integrity. And lastly, availability, so is the least priority in the IT world. When we look at OT world, that is completely reverse picture. The priority number one is availability. You can't afford your production to stop due to a cyber attack. That's for clear reasons. And then integrity is obviously second priority, because you need to make sure that the data that is transmitted paints the right picture. But suddenly is less and less important if some hacker will be able to see what is the temperature on my production line. That is less important, right?
Yeah.
As long as, and it becomes really clear what this is crucial for safety, cybersecurity in the OT world, is because if hackers from the outside of the factory walls are able to control my processes, they can pose a risk not just to the quality of my processes and products, but also to the safety of my people on the shop floors.
Yeah.
Unfortunately, the regulators are not they are still wrapping their heads around how to do it practically. They are putting the word out there, they're making it urgent, but there is not necessarily a wide availability of guidelines on how you practically do it. And that's where ISA comes into play with its standard 62443, which is very widely adopted and puts out some of the best practices and standard approaches that are very helpful to navigate the cybersecurity in the OT world.
Which is helpful, so that organizations don't feel like they're alone in this, and with that cross-section of the background information and potentially reaching out for external support, but a critical element of business continuity. And like you say, safety. And as you get that combination of human-centric approach, humans being in the middle of perhaps a robotic production process to handle exceptions or so on, then that safety in that circumstance needs to be fail-safe. Leonardo, many thanks for the insight and unique perspective you brought to our conversation today. We very much appreciate your time, and thank you for joining The Tech Between Us. To dive deeper into Industry 5 and explore Mauser's rich content on this subject, visit our Empowering Innovation Together page for videos, technical articles, and more at mauser.com/empowering-innovation.